Welcome to MyProjectBazaar.com. Let me discuss about the process energy efficient orthogonal frequency division multiplexing scheme based on time frequency joint channel estimation. Let me discuss about the abstract of the project. TDS OFDM provided poor performance for fading channel with long delays. Even it provided more spectrum efficiency than the CP OFDM. To overcome above mentioned problem by implementing time frequency training orthogonal frequency division multiplexing, where it worked based on the time frequency joint channel estimation under cooperative sensing scheme to optimize the energy efficient by reducing the power of the God interval. For acquiring partial support information, the above mentioned scheme uses the time domain pseudo noise sequence for estimating the channel exactly. The above method used frequency domain pilot analyzes the performance of TFT OFDM scheme with CS outperform the conventional scheme. Compressed sensing is a signal processing technique for efficiently acquiring and reconstructing a signal by finding solutions to undetermined linear systems. This is based on the principle that throughput optimization, the sparsity of a signal can be exploited to recover it for fewer samples than required by the Shannon-Nyquist sampling theorem. For achieving higher efficiency, the power of God interval can be reduced in order to acquire partial support information of the channel. This method utilized time domain pseudo noise sequence. This OFDM can outperform than the conventional OFDM scheme, even the channel having long delay spread. Let me discuss about the flow diagram for our process. Initially, the system has been modeled. OFDM symbol is generated based on the time domain Pn sequence which having length of m, and also the OFDM block which are having length of n. Then each OFDM block converted frequency domain using FFT. A fast Fourier transform algorithm computes a discrete Fourier transform of a sequence or its inverse. Fourier analysis converts a signal from its original domain, often time or space, to a representation of in the frequency domain and vice versa. A FFT rapidly computes such transformation by factorizing the DFT matrix into a product of sparse factors. Then the small number of frequency domain pilots are added with the frequency domain signal. Then time frequency joins channel estimation based on CS. Initially acquiring time domain based partial support information with the help of received PN sequence can acquire a partial channel support information. The good correlation property of the PN sequence acquired efficient partial support information with the absence of IBA removal. Next, the estimation of channel sparsity level can reduce the system complexity. The cyclic reconstruction of the OFDM block can be implemented by the simple add and subtraction operation, which is a relatively mature technique widely used in the conventional TDS OFDM system. Then the pilot can be extracted from the cyclic reconstructed OFDM block. Finally, the exact channel support estimation with PSI COSAMP by exploiting the obtained partial support can be used to extract the approximation of the target signal and the corresponding initial residual signal. Using the current samples, the algorithm computes a vector. It is highly correlated with the signal called the signal proxy. From the proxy signal that carry a lot of energy are located. The algorithm produces a new approximation by retaining only the largest entries in the least square signal approximation. Finally, the samples are updated so that they reflect the residual, the part of the signal that has not been approximated. Next, these 5 steps are satisfied. finally, performance has been evaluated based on the obtained received signal. The performance analysis of the proposed scheme in terms of energy efficiency and Cramer-Roy lower bound of the time frequency joint channel estimation based on PSA COSAMP together with the computational complexity. Let we discuss about the running procedure for our process. Select the main.temp file in the current folder, select the file and run for executing this process. Here time domain OFDM block signal and frequency domain OFDM block signals are represented in a graphical format, and this process will execution and here the process will take more time for execution. Here PSA SOECMP algorithm are running. After running this algorithm, the final stopping criteria, after reached the final stopping criteria, we obtain the BR and MSE graph. This is the time domain OFDM block signal, and this is the values of the time domain OFDM block signal. This is the graphical representation of frequency domain OFDM block signal, and this is the values, and this is the frequency domain received OFDM block signal. This is the frequency domain of received OFDM block signal, and this is the PN sequence of our received OFDM signal. This is the received frequency domain pilot signal. This is the pilot representation signal. Received frequency domain pilot signal, and this is the MSE performance comparison under CDT 8 channels. Here all existing conventional algorithm are proposed and compared with our proposed scheme varying the alpha value, and this is the MSE performance comparison under I2UVB channel for different existing and proposed method. This is the BI performance comparison under CDT 8 channel for our different methods, and this is the BI response for our I2UVB channel for our different existing and our proposed scheme by varying the alpha value. Here we analyze the energy efficient orthogonal frequency division multiplexing by including the pilot sequence and pilot power. Thank you.